So this idea of seafloor spreading is completely supported by our three key pieces of evidence. We want to be able to know those three, explain what is seen about them, and also how they support this idea. So our first one that we talked about was the age of rock on the seafloor. And so that is looking at how old the basalt is down there on the oceanic crust. And when you're labeling it on a picture, and really all three of our evidences, we're thinking about what's going on at that mid-ocean ridge and away from the mid-ocean ridge. Because this is really our focal point right here, that mid-ocean ridge in the middle of the ocean. That's where all this stuff is originating from. So when we're looking at age of rock on the seafloor, we notice a change when we look at the ridge and away. At the ridge is where we find our youngest oceanic crust, and the farther away we get from the ridge, the older that rock becomes. So we have a range of anywhere from 0 million years old right at the ridge, all the way to up to 200 million years old, far away from the ridge. So that's what our age of rock is showing. And we've noticed that that's consistent on both sides of the mid-ocean ridge, right? So another clue we have, or one of our biggest clues, is that that pattern is symmetrical around the mid-ocean ridge. Our second piece of evidence is sediment thickness. And when we think about the thickness of sediment, again, we're looking at that location at the mid-ocean ridge compared to further away. We can draw our sediment in here to make a visual for our pattern or our data. We see the thinnest right at the ridge and thickest farthest from the ridge. And again, I'm keeping that same consistent terminology, at the ridge and away from the ridge. I'm not looking to say close to the continent. Okay, I want to make sure I'm being specific. At the mid-ocean ridge and away. So we know the sediment thickens as we get further and further away from the ridge. And again, we see that happening on both sides of the mid-ocean ridge with that symmetrical pattern. And again, the oldest sediment, the thickest sediment is piled up on the oldest rock because we know it's had more time then to collect that sediment. Our final piece of data was that magnetic reversals. The idea that we're seeing the exact same symmetrical pattern on either side of the mid-ocean ridge with this piece of data. So again, the magnetic reversals are there because of the orientation of the Earth's magnetic field. And we notice that they alternate on either side of the mid-ocean ridge. Okay, I'm not going to ask you to draw this pattern in ever, but we want to know that it exists because, again, it's that key piece of evidence proving that the mid-ocean ridge is, in fact, the location where all these things are created from. The reason why we have this pattern symmetrically on either side of the ridge is because this is where everything originates. We have that core heating up the interior material, pushing it towards the Earth's surface, and when that magma comes out and cools, it's pushing that crust in opposite directions, creating this divergent boundary in the middle of the ocean. And so we see this data pattern of age, sediment thickness, and magnetic reversals the same on both sides because everything is originating from right here at the ridge. And it's doing that because of that ridge push force we're seeing underneath the Earth moving the crust on top. So for your learning target 4, we want to label up the following things, and then you want to be able to explain what the evidence is. Okay, what do we see? So if you're describing basically your diagram up here, or to somebody, well, what do we know about the age of rock? And this is where we should really see that consistent at the mid-ocean ridge and away from the mid-ocean ridge. That's kind of the phrasing that you should use when you're describing what is seen, along with, of course, that key word of being symmetrical on either side.